So now we're going to learn about modular arithmetic for negative integers. In this first part, part one, we're only going to work in the integers mod 5. Now remember, this is a really small world. There's only 5 numbers in the integers mod 5. Think of it as a set like this. We have the numbers 0, 1, 2, 3, and 4. Those are our only numbers. Those are in the integers mod 5. All right, something that's going to help us a lot with this is this statement. A is congruent to B mod 5 if and only if. Now remember, this is from a previous video. I talked about this, that this is the same as saying that 5 divides A minus B. And remember what 5 divides A minus B means. 5 divides A minus B is really the same as saying that A minus B over 5 is equal to some integer. Right, so if this is the same as this, and this is the same as this, right, then that means that this and this are the same. All right, and so that's what we'll do. We'll use those together. And this is the thing that we want to keep in mind. What I have circled in blue there. A is congruent to B mod 5 is the same as saying that A minus B over 5 is equal to some integer. When you do this math right here, you get an integer out. All right, so I want to show you some somewhat interesting things. Negative 1 is congruent to 4 mod 5. This is true. Well, let's just check to make sure it's true. And we'll use the thing in blue to help us. This is true. Remember, the things in blue are the same, right? A is congruent to B mod 5. It's the same as saying that A minus B over 5 is equal to some integer. So look here, this is like our A, that's like our B. So if negative 1, which is taking the place of A, is congruent to 4, which is taking the place of B mod 5, then that means that negative 1 minus 4 over 5 is equal to some integer. And in fact, you can see that's true, right? So that makes negative 5 over 5, which is negative 1, which is, in fact is an integer. So that tells us that, in fact, negative 1 is congruent to 4 mod 5. All right, let's look at another one. Negative 2 is congruent to 3 mod 5. Okay, we'll check to make sure that that's true. Well, that's true because that's true if negative 2 minus 3 over 5 is equal to some integer. This again gives you negative 5 over 5, which is negative 1, an integer. Right, so it's true that negative 2 is congruent to 3 mod 5. And similar calculations, like we've done over here, would show us that, in fact, negative 3 is congruent to 2 mod 5. And negative 4 is congruent to 1 mod 5. And negative 5 is congruent to 0 mod 5. Okay, now what I'm trying to show you here is that there's this cyclic or cyclical relationship between all of the numbers mod 5. So let me draw this cyclical thing with the only numbers mod 5, which are 0, 1, 2, 3, and 4. So if you go this direction, this is going into the positive. If you go this direction, that's going into the negative. Right, so you could think of this as these things are on like a circle, or maybe even a clock. Now the clock is kind of weird because there's a 0 at the top and there's only 5 numbers on it. So maybe it's a clock on some other planet where they have shorter days or something, you know, something like that, or shorter hours or what have you. Maybe even we want to, I'll draw a circle to indicate that circular relationship. We have 0, 1, 2, 3, and 4. Now remember, moving around the circle clockwise is moving into the positive. So this is positive. Counterclockwise is negative. So what I mean by this is, let's say we wanted to know what this is right here. -1 is congruent to what mod 5? A way that we could figure this out is starting at 0 and going backwards. We go like this. This is -1. Or yeah, so going back, so if you're going counterclockwise, you see that 4 is -1. So that tells us that we have 4 here. All right, now maybe this is hard to understand, and I'll just do all these real fast so we can kind of get a better idea. Okay, so this is 0, right? -1, -2. So 3 is -2 in the integers mod 5. Okay, how about this one here? Let's look at this one here. Okay, let's see. 0, -1, -2, -3. Oh, okay, so -3 is just 2. Okay, now moving on to -4. What is -4 mod 5? -4, let's see, 0, -1, -2, -3, -4. So -4 is 1 mod 5. And now lastly, -5. Okay, let's see, -5. Okay, so I'll start up here with 0. So 0, -1, -2, -3, -4, -5. Oh, it's 0. You see how I did that? All right. Okay, and that's really how you can deal with negatives. Now, of course, you might have something a little harder, and let's look at how we would do that. I'm going to get rid of this circle because I'm going to have to underline a bunch of stuff for this one. Okay, negative 27 is congruent to what mod 5? So you could do something like this. Okay, we're at 0. This is at 0, right? So negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9, negative 10, negative 11, negative 12, negative 13, negative 14, negative 15, negative 16, negative 17, negative 18, negative 19, negative 20, negative 21, negative 22, negative 23, negative 24, negative 25, negative 26. Aha, negative 27. Negative 27 is 3 mod 5. That's it. Now, maybe we miscalculated, right? Maybe we miscalculated. Well, we could just use this thing right here to check, right? Since the things circled in blue above are equivalent ideas, right? This is true if and only if negative 27 minus 3 over 5 equals some integer is true. Okay, so let's check. Is negative 27 minus 3 over 5 some integer? Let's see. Negative 27 minus 3 over 5. That would be negative 30 over 5. That would be negative 6. Negative 6 is an integer. So in fact, yes, this is correct. See how I did that? Okay. Let's look at another one. Okay. How about negative 103? What is that congruent to? Mod 5. Well, this would require a lot of rotations and counterclockwise, right? Let's see. 0, 1, 2, 3, 4. Those are all of our numbers, mod 5. And we're going to have to go into the negative. Let's see. Let's just start looking at this. That's 0, right? Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9, negative 10. Negative 11, negative 12, negative 13, negative 14, negative 15. Do you see what's going on? Negative 15 is 0. Okay, negative 16, negative 17, negative 18, negative 19, negative 20. Negative 20 is 0. Right, negative 20 is 0. Okay, let's just go a little bit more. Negative 20. Let's see, negative 21, negative 22, negative 23, negative 24, negative 25. Negative 25 is 0. So if you're a multiple of 5, then you're 0. Now, clearly that's not a multiple of 5, right? But a lot of it is. A lot of negative 103 is a multiple of 5. Let me show you what I mean. 103, right, positive 103, this is 100 plus 3. Right, so now to make it negative, right, if we make this negative, we have to make both of these negative. So negative 103 is equal to negative 100 minus 3. Now divide by 5. We divide by 5, we divide by 5, we divide by 5. Negative 100 over 5, this part right here, right, this is just going to be 0. I mean, it's not going to be 0, but so mod 5, that would be 0, right? Because the remainder, when you divide negative 100 by 5, would be 0. So mod 5, this is just basically 0 here. The only remainder when you divide by negative 103 by 5 is negative 3. So what I'm saying here is that, let me get rid of some of these blue hash marks here. So what I'm saying is, when you do this math, right, negative 103 divided by 5, you're going to get some quotient there, and your remainder is going to be negative 3. So what does that tell us? Now think about this, right? That tells us that you have a negative 3 here. So negative 103 is congruent to negative 3 mod 5. Well, what is negative 3 mod 5? We can see that here. 0, negative 1, negative 2, negative 3. Oh, okay. So that tells us that negative 103 is congruent to 2 mod 5. Okay, now maybe you're not entirely sure that your answer is correct. Well, that's okay, because we have a way to check. The way to check is with the blue circled equivalents above. Remember, this is going to be true if and only if negative 103 minus 2 over 5 equals some integer. Well, does it equal some integer? Let's do the math. This would be negative 105 over 5, right? Let's see, I guess that would be, if you did the math, that would be negative 21, right? But you don't even really need to do the math. All you need to know is that it's some integer. Let's see, 5 times, let's see, no, it's not, it wouldn't be negative 21, would it? Let's see, 5 times 20, I guess that would be right. Yeah. Let's see, one way you could do this, right, is you could write this as negative 100, do it like this, negative 100 minus 5 over 5 over 5. So that'd be negative 20 minus 1, that's negative 21. That is in fact an integer. Yeah. So, okay, now we found that this is true, so that tells us that what we have right here is true. So negative 103 is in fact congruent to 2 mod 5. That's how I would do it. That's it.